Bismillahirrahmanirrahim. Welcome back, class. Today we will start the exercise 1.3, and same day exercise 1.3 is also based on the matrices, and there will be some operations like addition, subtraction, multiplication, and soon we will apply the same multiplication procedure as well. So in the current exercise, we are just going to deal with the addition and subtraction process. So make sure you have to put a focus on the video from starting at the end of the lecture. So without wasting time, let's start the topic. Exercise 1.3, matrix and determinant. Okay, class. In this exercise, the first question it is demanding from us, that question number 1 is saying that if A is equal to 3271, B is equal to 3, 6, minus 1 and 4, and C is equal to 4, 3, 2 and 4. Same, D is a rectangular matrix and E is a rectangular matrix. Just focus on the board that three of them, the matrices are in the square form and the two of them are in rectangular form. So we have to just use these matrices to solve the following parts, such as like the first part is A plus B. So in this form, we have to add the matrix A with the matrix B. So A plus B will be like, the first we have to write matrix A, 3, 2, 7, 1, and along with that matrix B, 3, 6, minus 1 and 4. ओके क्लास, यहाँ पे एक चीज आपको अपने माइंड में रखनी है, द मोस्ट इम्पॉर्टेंट पार्ट, कि आपको जब कोई भी नंबर को ऐड करना है किसी दूसरी मैट्रिक्स के साथ, तो मेक श्योर कि आपके पास जो पोजीशनिंग है उस नंबर की सेम सेकंड मैट्रिक्स में भी उसी जगह पे जो नंबर होगा उसी के साथ आप उसको प्लस करोगे. So the rule will be like just like the same. You have to add the number along with the another number. Just make sure the cofactor of that number will be same. Okay. So A plus B is equal to 3 is going to be my plus with the 3. 2 is going to be add with 6. 7 with minus 1. And 1 with 4. It is very simple rule. You have to just put a focus on the position of that number, and soon will we get the main idea how to add those matrices in a simple way. Okay, next we have to just add the numbers. Just like 3 plus 3, 6, 2 plus 6, 8, plus minus, minus, 7 minus 1, 6, 1 plus 4, 5. Okay, this is the answer of first part. Second part, you have three parts like matrix A, matrix B and matrix C. So make sure when you write the matrix, you have to put the same order that is demanded in the same part, like A minus B plus C. So first you have to write matrix A, 3, 2, 7, 1, matrix close, a negative sign, then a matrix B, that is 3, 6, minus 1 and 4. And then along with the matrix C, that is 4, 3, 2, 4 and matrix close. So the rule will remain same. You have to just put a focus on the position of that number. According to the cofactor, the same number is going to be added with the same positioning number, like 3 plus 3 plus 4. But in these matrices, there is a negative sign. So I'm just converting the positive sign into a negative. So this 3 is belong to the first matrix, and this 3 belong to the second matrix, and 4 belong to the third matrix. Moving towards the second number, 2 minus 6 plus 3. Next, 7. We have two minuses here, so I will use the bracket form, and same plus 2, the third number of that Now the last one, 1 minus 4 and plus 4, and the matrix close. Okay, now last part we have to add and subtract, such as like this. Negative and positive will be always a negative, so 3 will be cut down the 3. Okay, next, plus minus minus, 6 minus 2 is equal to 4, and 4 plus 4 minus 3 is equal to minus 1. Okay, next, 7, we have two negative signs, minus minus and plus. So 7 plus 1, 8, 8 plus 2, 10. And the next, plus minus minus, 4 minus 1 is equal to minus 3, and minus 3 plus 4 is equal to plus 1. So this is the answer of second part. Okay class, now moving toward the third part. Again, there are three matrices, and we have to just write the same order as it is written in this part, like B plus C minus A is like this. First you have to write the matrix B, 3, 6, minus 1, 4, matrix close. The second one is matrix C. So C is equal to like 4, 3, 2, 4, and the last one is negative A. So we have to write just like this, minus A is equal to like 3, 2, 7, 1, and matrix close. So the positioning of that number will be remain same. You have to just pick out the number along with the place of that number. So add with the next number and then add with the or subtract with the next number. From this you can get the easiest way to solve the number of matrices in a small step, like B plus C and negative A is equal to, so 3 plus 4 and minus 3. This is a part of first cofactor. Second, 6 plus 3 minus 2. The second cofactor, minus 1 plus 2 and minus 7. The third cofactor, and the last one, 4 plus 4 minus 1, and the matrix close. Now we have to just apply the methodology of Demas, that like 3 plus 4 is equal to 7, and 7 minus 3 will be like 4. Next, 6 plus 3 is equal to 9, and 9 minus 2 is equal to 7. Next, minus 1 and minus 7 is equal to minus 8. Minus 8 and plus 2 is equal to minus 6. Next, 4 plus 4, 8, and 8 minus 1 is equal to 7. So this is the answer of B plus C minus A. I hope you're getting the main point of that addition and subtraction. So moving toward the fourth part, again there are three types of matrices, C, negative B, and positive A. So the arrangement of that matrix will be like same, that C minus B plus A is equal to, first we have to write the first we have to write the C matrix, which is equal to like 4, 3, 2, 4, matrix close. Next, negative matrix B, 3, 6, minus 1 and 4, matrix close, and the last one is positive A, which is 3, 2, 7, 1, and matrix close. Same, 4 is going to be subtract from 3, and the remaining answer will be add with the positive 3. So the solution will be like same, 4 minus 3 plus 3, 3 minus 6, and plus 2. Make sure class you have to just follow the places of that number through which you are going to get the perfect answer. So the next part is making the third cofactor, like 2 minus, here there are two negative signs, so from that I will use the bracket form, like negative 1 and in the bracket form, and the next plus 7. Okay, so the last cofactor 4, minus 4, and plus 1. Okay, this is the arrangement of three matrices. So the next, I'm going to just like negative and applying the Demar's rule. Negative 3 and positive 3 will be cut down, and the answer will be like 4. Next, 3 plus minus minus, minus 3 and plus 2 is equal to minus 1. Next, there are two negative signs, so minus into minus will be equal to plus. So 2 plus 1 is equal to 3, and 3 plus 7 is equal to 10. And the last one is minus, plus and minus minus. 4 will be cut down the 4, and the remaining one is your answer. And this is the answer of fourth part. Now moving to part. Now in this part we have demanding like D plus E. So in this form we will just like the first D matrices and then matrix E. So the both matrices are rectangular form. That's why the solution is possible. So do 1, minus 2, 4, 3, 1, matrix close, positive sign. Next, matrix E, minus 1, 2, 4, 1, 3, 5, and matrix close. Okay, so the step will be again remains same. You have to just focus on the place of that number through which you are going to add or subtract. Okay, so 2 plus into minus 1, and the next 1 plus 2, next minus 2 plus 4. Moving toward the second row, 4 plus 1, next 3 plus 3, and the last one 1 plus 5, and matrix close. So just we are going to just apply the Demar's rule, that is plus minus minus, 2 minus 1 is equal to 1, next 1 plus 2 is equal to 3, minus 2 and plus 4 is equal to plus 2. Okay class, so the next 4 plus 1 is equal to 5, and 3 plus 3 is equal to 6, and 1 plus 5 is equal to 6. So this is the answer of D plus E. Okay, now for the last part. In this part, he demands the E negative D or E minus D. So we will just follow the method of the positioning of E and D matrices. Like E minus D is equal to matrix E minus 1, 2, 4, 1, 3, 5, matrix close. Next, the matrix D, 2, 1, minus 2, 4, 3, 1, and matrix close. Okay, so minus 1 along with the minus 2, second 2 minus 1, next 4 minus into minus 2. Here we have two negative signs. The last one 1 minus 4, 3 minus 3, and 5 minus 1. Okay, minus 1 and minus 2 is equal to minus 3, plus minus minus, 2 minus 1 is equal to 1, next minus minus plus, 4 plus 2 is equal to 6, last 1 minus 4 is equal to minus 3, plus minus minus, 3 will be cut down the next 3, which is equal to 0, and the last one 5 minus 1 is equal to 4, and this is the answer of last part. Now question number 2, and in this question, the question says that find the additive inverse. So in the additive inverse, we have to just reverse the sign of those numbers. If the numbers is written in the positive form, so we have to just reverse the sign into a negative, and this will be the answer. Like in the first part, if A is equal to this, so the inverse will be like minus A is equal to minus 3, minus 1, minus 2, and minus 5. So simple, this is the additive inverse of the given matrices. Moving toward the next part, B. In the B form, there is a negative number. So when we are going to find the additive inverse, so the negative sign will be converted to a positive one. Just like this, the additive inverse of matrix B means minus B is equal to plus 1, minus 2, minus 4, minus 5, and matrix close. Very easy. Third part, C is equal to minus 3, and there is a negative 4, so it will be converted into the positive 4. So this is your answer. Now D form, the negative D is equal to a negative square root of 2, negative 5, negative 4, negative 3, square root, and matrix close. It is very easy. So you have to just convert the sign from positive to negative, or if there is a negative sign, so it will be converted into a positive. Now negative E is equal to minus 3, minus 2, minus 1, minus 4, minus 5, and minus 3, matrix close. The last part, the negative F, will be like just minus 3, and there is a negative 7, it will convert into the positive 7. Because when with the two negative signs react, it will create a positive sign. That's why minus into minus, this minus will be turned into a positive 7. So these are the answer of question number 2. Okay class, now moving toward the question number 2, and the remaining part of the question number 2 is that you have to just subtract the A from its own element, and the answer will be like 0. So we have to use the matrix A and minus it with own element. So the negative sign will be subtract all the element and it will create a 0, and we have to just prove it like A minus A is equal to 3, 1, 2, 5 minus again 3, 1, 2, 5, and matrix close. Next, 3 minus 3, 1 minus 1, 2 minus 2, and 5 minus 5, bracket close. In the entire cofactor session, like 3 will be cut down 3, 2 will be cut down 2, 1 will be cut down like 1, 5 cut down 5. So all the numbers will be like equal to 0, 0, 0, and matrix close. The next part is that solve E minus E, and the solution of those matrices will be also equal to 0. So the same solution that we have done in the first part, we will apply in the second part as well. So like E minus E is equal to 3, 2, 1, 4, 5, 3, matrix close, minus again 3, 2, 1, 4, 5, 3, and matrix close. So 3 minus 3, 2 minus 2, 1 minus 1, 4 minus 4, 5 minus 5, 3 minus 3, and matrix close. And all the number will be converted into the 0, like positive, negative, same, all the number will be cut their own form and make a 0 unit, like 0, 0, 0, 0, and 0. So this is the answer of remaining part of question number 2. So class, this is a solution of question number 1 and question number 2 of exercise 1.3. The remaining two questions will be uploaded soon. So stay tuned. Till that, Allah Hafiz.